Hi, today we're going to talk about .NET Core 3.1 long-term support and free tools for pushing quality and security left. So the problem statement is this. There's been study after study after study that says more we can head off bugs by putting tooling and other things in the hands of the developers, the better off we are. And that bears out in Magenic's real-world experience, too. The problem is not all shops have an endless amount of money to spend on one of the big-ticket quality tools, and there are a bunch of really good ones. Veracode, Endepend, there's a ton. But they are spendy. I'm not making a value statement as to their worth, but rather just their cost. And if your team is on a budget or is constrained by a budget cycle, it would be nice to know that you can push quality and security left on a budget. Because this video is about .NET Core, and we're assuming that teams are doing their best to be on 3.1 long-term support until a new long-term support version comes out, which, by the way, will be 6 and then 8 and then 10. So although .NET 5 is coming, it won't be LTS. .NET 6 will be LTS, but that's not going to be for a couple of years. We're assuming that teams are setting their sights for stability and support from the vendor on .NET Core 3.1 LTS. That is an excellent decision. And the primary tools that most of the teams that we work with use are VS Code or Visual Studio 2019. So the tools that we use had to integrate pretty seamlessly into those, ideally giving us the usual light bulb and screwdriver icons in our code editor, and also emitting complaints into the normal build output flow. Just a reminder, right? This is the famous curve. This is actually by a guy named Matt Archer, and I really suggest that you read his articles. He's great. And I was looking for a really simple graphic. There's a bunch of really good work done by Barry Baim, and a bunch of good stuff about this in Microsoft Press and O'Reilly and whatever. But Matt Archer's blog just super boiled it down for me. And you can see that the sweet spot is post requirements and in development. If we can stop a bug from happening by making sure they're following a best practice, we'll get the biggest bang for our buck. That is to say, the lowest cost and consequence. I wanted to find some tools to use, and this is the ones I settle on. Editor Config, which is the plugin that is detected. It's just a file, right? It's like any other .config file out in the universe. And it is detected by VS Code and Visual Studio. And if it's in the root of your project, it will apply the rules therein. And you'll get feedback in the form of light bulbs and screwdriver icons and compiler output as you'd expect. This is the one that I like. Feel free to modify it to suit your needs and put it into your projects. So absolutely free, kind of built into the tooling. And then there's two NuGet packages. Security Code Scan, which is actually contributed to the NuGet universe by our good friends at GitHub, who are now owned by Microsoft. And as security code scanners go, it's a pretty gosh darn good one. Kind of the next level up on that would be SonarQube, but SonarQube doesn't really have a way of interacting with our IDE, and that was one of our criteria. But for a little deeper, more insightful scan, integrating SonarQube into your CI/CD pipeline would be pretty great. And there's an open source version and there's a commercial version, and they have, there are pros and cons to the commercial version. And then Microsoft.CodeQuality.Analyzers, which uses the Roslyn compiler engine. They both actually end up using Roslyn compiler engine, and it's obviously contributed to the community by Microsoft. And then, not for nothing, have a unit test framework. I like MS Test version 2 very much. I found it very productive. Some people like NUnit, some people like XUnit, some people like something else. It doesn't matter what you like. It matters it gets used. I'm going to use my famous customer API repo for this. We're going to use the version in the .NET 3 folder. I also have a .NET 2 version. So let's dig into it. Hi, let's start with editor config. As you can see, I've included it into my project. The layout of editor config is right there. You can look at the docs.microsoft.com site to see all the different things you can configure in here. A good place to start would be to grab mine off my GitHub and then go through the various rules and mark them up for yourself. You can see that there's a set of just name value pairs. And if the value is false, there's no following argument. And if the entry is true, then you can set a severity level. And then our two NuGet packages are easily seen. If we look at the NuGet packages and go to installed, you can see that we have added security code scan and code quality analyzers to our primary project. I don't usually bother to do that to test projects, and so you can see I didn't select them. And that materializes in our solution tree under dependencies and analyzers, and then under each of the analyzers that's pulled in, you can see the rules that they have, and you can override whether or not that is never scanned at all, whether it is just a warning or whether it's an error. And if you're doing a crawl walk thing with your team, what I'd say is make them informational to start with, then upgrade them to warnings at some point when you've had a chance to do a couple quality bounces against your code. And then the ones that are truly worrying should probably fail the build. So that's those. So let's take a look. The next thing that is useful to consider is unit tests. And again, my examples are in MS Test. You should have some testing framework. And you can tell that I didn't put code quality or code analysis tools into here because, in fact, it doesn't yell at me about the fact that I have unused directives. So I could go through and do that. And you can see that I've written a bunch of tests. One of the tests that I strongly encourage you to write is anytime that you have an object that's going to be going over the wire, that you run a JSON serialization test against it. And what this does is you populate your model. And then I wrote a little helper that you can install as a NuGet package or get off my GitHub gifts and modify to suit yourself. And you pass in the type of object, and you pass in an instance, and you pass in the test context object, and it will serialize, deserialize, and compare all the properties. And it will do assertion checks. And so if any of the assertions fail, your test will fail. And this allows you to write a very, very compact serialization test. You can see I write one for each of my major data objects. The other kind of tests that we're used to when we're writing just good old-fashioned unit tests. And by the way, I want to point out that this is how you properly inject text context in MS Test version 2. And the test context object has many of our old familiar things, but it's also got a ton of new capabilities. So I would go and look at the documentation for that, but I tend to wrap that in a region boilerplate. And so here we have a traditional test method. One of the things that is probably wrong with this is that perfectly reasonably, at the very least, I probably ought to put a test category on this. And this, of course, is a unit test. And I probably ought to say test category wise, that I ought to say what kind of a test this is. And this is a functional test. And you can see that I'm invoking a library and trying it out, and that I have an assertion in it. By the way, tests without assertions in them are simply a test that your test code doesn't throw an exception. And I'm not entirely crazy about that as a thing. So you'll see that most of my tests either have implicit or explicit assertions in them. In the case of the serialization helper, the assertions are buried in the helper. And so, for example, here is my controller test class, and you can see I have broken it down into regions because I like that. And I can do a set of tests. So here I can spin up a logger instance using the MS test logger that I wrote. And what does this do? This creates a logger that writes to the MS test test context write line. And so what that does is it puts any logging done by the code under test into the test output. And that's super helpful. I spin up an instance of my controller and I pass in my logger, and then I do some tests. Notice here I'm using the new discard syntax because I really don't care. And in fact, the actual assertion is expected exception. And in this case, what I expect to have, because there is no key named zzz, is that I'll get a key not found exception. Here is a positive test that we expect there to be something, and my assertion is that the entity I get back is not null, and so forth. So this is a nice pattern you can follow, and if you have the enterprise test SKU, or you want to install a third-party test coverage tool, you can run your unit tests, and then you can right mouse click and do an analysis of code coverage. And this takes just a minute. In the code coverage results, you'll get a breakdown of the percentage in blocks not covered. You'll notice here that actually I'm doing pretty well in terms of my code coverage percentage. So my code coverage is hovering well above 80, which is nice. And you'll notice that I don't bother to test the tests. In other words, I exclude from code coverage tests because I really only want to see code coverage on the libraries under test and not on the tests themselves. And this attribute is widely supported across a bunch of different test types. And again, there's a little bit of cleanup I could do here by removing the unnecessary usings. So there you go. Quick, free code quality things to drive down your bugs, increase your quality and security. 2 NuGet packages, a configuration file, and the test engine of your choice.